Alright, so the way that this makes the most sense to me is by kind of like starting it off from where it begins. And for that, obviously in meiosis 1 and prophase 1 is when crossing over actually occurs. So in crossing over, and obviously these chromosomes are going to be like kind of wrapping together. I just don't really know how to exactly depict that with pieces of paper, but they will be like kind of winding together and condensing down. And crossing over is where they share parts of the chromosomes between the sister chromatids. So then when that happens, you get chromosomes that look like this, where you have different parts of each chromosome are going to be shared between all of the chromosomes together, which causes genetic variation. So then when you get more into meiosis 1 and into anaphase, when it starts to pull the actual chromosomes to different poles, and then you get cytokinesis, which creates the haploid cells. So then each cell has a different set of chromosomes there. And then after you get into meiosis 2 and you get to telophase 2 and cytokinesis, then you have the actual, like the strands like this would be in one cell out of the 4, so that would be like a depiction of 1. So then this is what can cause a lot of genetic variation throughout the body, and depending on where it's happening, obviously, is if it's happening in the sex cells, it can actually cause a lot of genetic variation and can do cool things like that. So that is crossing over.